Hi guys, so I'm going to take you through a possible way to approach the SAC, module 1 of outcome 1. You'll need a copy of the SAC document open in Word. Now mine's in Mac, so I'm going to toggle to mine, but the screen capture won't work. But if you have a look at the document, there's a few design tools that you've got to use there. One is the layout design, or a mock-up, and that shows the layout and the visual features on there. It also gives the names of the objects. There's an object description there that tells you what happens, what events are attached to particular objects. So for the button, mean, click function, it tells you it's an event, and it tells you what happens when the button is clicked. And there's also, importantly, the algorithms. And really the most important part for you guys is the ability to interpret algorithms and turn them into valid C# code. So that's going to be the focus of this. But first of all, I'm going to build the interface. So I'm toggling back now. And I'm just going to create a new project. All right, it's Windows Form application, and I'm going to call it Module 1 Trial SAC. I'm going to try and call it that. Okay, there we go. And that'll bring up the little grey form. Waiting. There we go. All right, so I'm going to resize that. It doesn't specify size, but you can be the judge of that. About that size is big enough. I'm going to select the form, and I'm going to change the form's title. That's the text. Text is what the text actually shows depends upon the widget you're changing it on, but I'm going to call it Module 1 SAC. That'll do. All right, and there it is. That's changed the title up there. And now there's a couple of buttons we've got to create. I'll just drag a button in. Listen, if you haven't got the toolbar showing, you can just go to the toolbox and then click the pin, and that'll pin it there. I'm going to resize that button, change its name, and the text. So let's go to the text first, and this is for calculating the mean. And if I go up there and change, you've got to press enter too, otherwise sometimes it doesn't take. And the naming conventions. Remember that in camel case, the prefix tells you the type of object it is, so button and mean. And that's actually spelled out in the document you've got there, the mock-up. Okay, that's cool. And I'm going to, rather than create another one, I'm just going to select that one and copy it. And then I've got another one. I know it's exactly the same shape, same dimensions, so I can actually just put that there, and helps with the interface look and feel. So I'm going to change the name of that to button mode, because that's going to calculate the mode of the student data. And I'm going to change the text on that to mode as well. Okay, there we go. Now we need a couple of labels, just regular labels there. I'm just put one over to the side. There's a really bad interface, but it doesn't matter. That's cool. Text for the label, I'm going to leave the label text there for the moment. The size of the label depends upon the size of the font we're using. If you want to change it, you can't change it there. You come into the font. I haven't specified a font size, but if we put it to something like 12, it'll be legible. And then I'm just going to, I can copy and paste that as well. So select that one. And there we go, label 2, and I'm going to change the name of those two. So label 1, the name of that is label, and the abbreviation for that is, sorry about that, is LBL, mean. You can use any reasonable naming convention you like, and this one is LBL. Helps if you use a standard, because then you can actually find the objects you're looking for. So there we go. All right, that's our interface done. If you want to remove that text, you can. It doesn't really matter at this stage. If you pull the text out, the label compresses in size, but it'll resize itself when we actually use it. Doesn't matter. Okay, now, if you toggle back and have a look at the specifications in the document, the SAC document, you'll see that the button mean on click, now I've actually misnamed that, it should be just button mean click. It's an event, which means that it responds to some kind of user interaction, some kind of user action, and there's a description of what it does. So I'm going to copy that So copy all of that description, and I'm going to come back in and I'm going to add the event handler to mean. So to do that, all we do is double click on the mean button itself, and Visual Studio drops us in there. I'm going to put in some comments. This we haven't done this, but if I put some comments in here, I'm just going to put in a /*, a couple of enter points, tab, and then */. Anything that goes in between there is actually a comment. It's ignored by the compiler. But internal documentation is important because it actually allows you to, and other programmers when you get sacked, to actually go and see what the intention of a particular method was. And we'll go through this in more detail later. This is not an accessible component of this module. But it says when the button is clicked, it will calculate the mean of the sample student data and display the result in label mean. That's pretty straightforward. Now I'm going to toggle back again to that document, and there's some sample data there. It's just an array of integers. You can see that. I'm going to copy that. Now, I want that data to be available for every function of this class. There's my class there. It starts with public partial class form1 : form, which means that form1 inherits the form object, and it goes from that curly bracket right down to the paired curly bracket that's in line with that. You can see that there. So I'm going to actually I'm going to come up to the top of my class there, put an enter, and I'm going to paste that student data in there. All right, so there we go. I'm going to use that. That means that I can get to it wherever I want inside here, and I need to get to it inside the button mean click function. So now there's an algorithm for this. Now the algorithm is pretty simple. You know how to do this. But what I'm going to do is I'm going to toggle back again. I don't think you can see me doing this. I'm going to copy all of the algorithm for calculating the mean. I'm going to come back in. I'm actually going to paste that in there so I can see the algorithm. And I'm just going to put in a block comment again. And I'm just going to paste it in here. And there we go. Now you'll know it's a comment because it's in green. I'm going to actually, there is a way to do this all at once, but I can't be bothered finding it. I'm just going to indent this so I can see what happens with it. If you use the indentation, indentation's important to code to making it legible. Indentation, use of white space, you can be profligate with the amount of space that you use. It makes sense, to actually keep the code clear and maintainable. There we go. There's my algorithm. I'm going to turn that into valid C# code. This is the cool bit. Right, this line says set a variable sum to be equal to 0. Well, that looks like an integer. So, selecting the correct data type is important. It's one of the requirements of the SAC. I'm going to call it sum, and I'm going to be setting it to equal to 0 and semicolon. All statements must end with a semicolon. There we go. A couple of lines. So now there's an iteration. There's a for loop there. And it says we're going to actually do something by setting a variable loop counter to 0 to the length of student data, which is our array up here. So for however many items there are in there, I think there's 100, I'm not sure, it's going to do it from 0 to less than 100, or less than the length of student data. So we know that an array goes from 0 to n-1 items. So we're going to just hack up a for loop, and it's going to be simply for int. I've got to declare the variable loop counter equals 0, colon. That's the end of that little statement. That's my initialization. Now I'm going to do a test, and I'm going to say while loop counter is less than student data dot length. Oops. Dot length. Spelled with an L. There we go. Semicolon. And then there's the increment, the update, and it's going to be loop counter plus plus. So it's going to add 1 to loop counter every time it goes through back to the top of the loop. And there's my loop. That's easy. Now, inside the loop, we've got a little sum in here, a little addition. It says sum is set to be equal to sum plus the contents of student data, the loop data index into student data. So it's student data, and we'll go to the whatever item, whatever number loop counter is currently pointing to, and we'll get the contents of that bucket. I don't need that space there, and there it is. So if to desk check this, loop counter starts off being equal to 0. It says, is loop counter less than student data.length? It is, because student data.length is something like 100, all that. So it says, okay, come down here and set sum is equal to 0, set sum to be equal to sum, which is 0, plus student data 0. Well, student data 0 I think is 32. So after it goes through the first time, the first iteration of this loop, sum equals 32. Goes back up to here and adds 1 onto 0. So loop counter now equals 1. Comes over here and says, is 1 less than student data.length? It still is, so it does it again. Now it goes to student data 1, index 1, which is 59. So it says, okay, 32 plus 59 equals, I don't know, 80, 91 or something like that. So cool, there we go. So we've summed all of the items in that student data array. Now to calculate the mean, if we go up to our thing, it says mean is set to be equal to sum divided by the number of items in student data. There it is there. Okay, so that's pretty cool. So we can just do, now we know that a mean's unlikely to be a whole integral value, so we better use a floating point number, and let's call it mean equals sum divided by student data dot, student data dot length. There we go. And that's our algorithm coded out. Now, if we run that, we've got to display it, don't we? That's the last line there. So we're going to go and do label, I know how to find it because I gave it the name, dot text, set the text of the label to be equal to mean. But text is a string and mean's a floating point number. So we're going to use the convert class, convert to string, there it is there. Use type ahead. Type ahead is your friend. There we go. Mean statement ends in a semicolon. And that's it. Now, you should be a bit worried about this line here because when we divide an integer by an integer, when we do integer maths, the result can only be an integer. And we're trying to store an integer in a float, which is fine because an integer, it's just a float. A float is just an integer with a decimal point. So if it comes up with, 62, then it will just represent 62. It'll truncate it. So if we run this, I think that it's probably it won't generate an error, but it will generate a logic error. In other words, we won't see the right result. You may not actually know it. So if I run this, there it goes, 62. What a guess. I've done this before. So what we need to do, you have to think there's something wrong with that. We're going to just convert these really quickly into a float. And we can do that just by, oops, I can't change that while it's running. Got to stop the process. So I'm going to turn this into a float just by, this is called casting. I'm just putting it through a filter, really. I can do that. There we go. And this time, if I run it, we should get a decimal value or a floating point outcome. There we go, 62.38. Cool, beautiful. Now, the mode. Same process. If you go back and have a look at the document for mode, there's an algorithm there. You know how to work out the mode. But this is a bit of a cool way of doing it. To work out the mode, you know that mathematically what we need to be able to do, I better go back to design, to toggle between the design and the code behind. There's the design, there's the code in the background. So I'm just going to double click on mode and it's going to create that method for me. Create the method for me. Something's screwy here. Oops, that's because it's still running. Sorry. All right, there we go. So there's my method. Now I'm going to do the same as I did before. I'm going to put the, I'm going to stick the algorithm in there as a reference point, and I'm just going to clean it up so I can actually see what's going on here. But what we're going to do is we're going to total up not the sum of the items in the array. We're going to actually total how many occurrences there are for each of those items. So for every occurrence of a student getting the mark 1, 2, 3, 4, 5, right through to 100, we're going to record that. And what we need to do is we need to record it in a data structure. We could do it as a whole series of variables and say, variable, mark 0 and mark 1 and mark 2 and so on. But we'd end up with 101 variables, wouldn't we? We'd end up with a variable for every mark from 0 through to 100, which would be 101 variables. But what we can do is we can use a data structure. We can use an array of integers that says, in the 0th item, we'll say how many people scored a 0. In the 1th item, how many people scored a 1. In the 22nd bucket, how many people scored a 22. In the 36th, how many scored a 36. So that's what we're going to do. So it starts off with a loop here. It says, again, loop counter is set to 0 to the length of student data. Go through and get each mark from the student data array one at a time. And then it says here, there's a mode array. Now, we haven't got an array called mode. We're going to have to do that. We're going to have to create it. And you'll have to choose what kind of data structure it is because that's part of the outcome. So it's an array containing marks. So an int array would be okay. It's actually, this is the one that's going to keep our score values in it. So we're going to declare an array, and we're going to see each time how many people have got, let's say we get marked 32. We know the first one is 32. How many people in our mode array have already got a 32? In other words, what's the total number that are already in mark 32? We'll get it, we'll add 1 to it, and then we'll put it back. So we're just keeping an array of counters, really. So let's declare the array first. So declare, this is internal documentation, array of counters. Oops. All right, there we go. So we're going to declare an array, it's int, then the variable type that you want to store, then square brackets, the name of the array, and I've called it mode array. All right, equals, we've got to use the new keyword, new, and then the type or the integers, and how many we want. Well, we actually need 101 because the marks are 0 through to 100, which is 101 possible marks. Okay, there we go. Now we've got a for loop, so we can do that. So that's pretty cool. For int loop counter, whoops, is set to be equal to 0 again, semicolon. That's our initialization. Now our test is loop counter is less than student data dot length, because we're going to check every item in the student data array, and we're going to do loop counter plus plus again. And if type ahead doesn't work as you expect it to, it means you're probably doing something wrong. All right, there's our loop. Cool. Now, what does the algorithm say? It says set a variable mark, and even if you don't understand what this is doing, you just have to code it. Set a variable mark to be equal to student data loop counter, the current item in student data. So let's do that. Now we're going to have to declare a variable, int mark equals student data loop counter. All right, there we go, semicolon. So that goes through and gets one after the other, each item in turn. Then it says total. So we've got to declare another variable called total this time, and we're going to set that to be equal to whatever's in the mode array at that marks bucket. So mode array, I'd encourage you to draw this and see what this looked like. Mark, okay, there we go. Semicolon, cool. Right, then whatever total is, we're going to add 1 to it. Now we don't have to declare the item again. Total equals total plus 1. And the easy thing to do there would be total plus plus. All right, but that's no big deal. Then we've got to put total back where we got it from. We've taken it out, updated it, put it back. So now we do mode array loop counter equals, put it back, total, where we got it from. So we've updated it. Now you could actually do all of that in one line. Let me show you this if you're interested. All right. So we could simply do mode array student data loop counter plus plus. That one line does exactly the same as those four. But you know, I told you I'd do the most verbose way so you can see what's going on. So what we should, if we run that, what we should be able to see at the end of that is in that mode array, how many people got each mark. So if I put a stop point there and actually run it, we can actually have a look inside the array and see what's going on. So let's run it. There we go. Now, so if we have a look in mode array, you can see it's got 101 items in it. Now there's something wrong there, I'm guessing. I don't think that's entirely kosher. Nope, it's not. That's definitely right. So we might have one of these. Let's have a look at our algorithm. We've got one of these right, one of these wrong. Mark equals student data total equals mode array mark. Total equals mode array mark. Total equals total plus 1. Mode array loop counter equals total. Oh, there's something not quite right there. Yeah, well, it's pretty obvious when you look at it. I actually have a look at that. Mode array mark equals total. I've used the wrong algorithm. I've looked at this one there. So it's got to be that. Okay, so if I stop that and then run it again, let's step through this. So we go and get the mark. Mark equals 32. If we have a look at the mode array to begin with, it's all set to be 0. All of the items are 0. Scroll down through there, and let's leave it on 32 and see what happens there. If I run it on again, total equals 1 now, because total was 0, we've added 1 to it. And if I put another stop point there, run it on again, and if we have a look in mode array again, if I look down into mode array, there we are. So if I scroll down through there, we get to 32, and we should see that there's been one instance of somebody getting 32. There it is. So now if I kill these, let's get rid of those dot points there, just clicking on those, and kill that one, and let's run it through the end, and we should see in our mode array, we should see, all right, nobody, nothing, 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 nothing. All right, 3 people got 24. One person got 27, 3 people got 29, and so on and so on and so on and so on and so on. Okay, so now we've worked out how many people got each mark. So the mode is now it's a simple thing. It's actually just going through and finding the highest count in our mode array. Well, we know how to do that. It just says here. We've got a couple of variables. We've got to set mode to be equal to 0. We've got to be able to set... I've got this in the wrong place, it doesn't matter. Mode to be equal to 0 and highest to be equal to 0. They're the two things that we're going to find. And then we've got a for loop that just goes through from loop counter equals 0 again, right the way through every item in our mode array. And if we find that instance in mode array at loop counter, 0, 1, 2, 3, or so on, is greater than the highest we currently know, starts off being equal to 0, then we'll update highest and we'll update our mode, because our mode is actually where that's found. So that's the bucket. So if we go and just create another int highest, and we'll set that to 0. There is another way, but that one works. And int mode, what bucket is it in? Because that's the bucket that we will need to know about. And then there's our for loop. For, again, int loop counter equals 0, semicolon. Loop counter is less than... What are we after? Mode array. Oops. Mode array dot length. There we are. Semicolon. Loop counter plus plus. So that'll step through every item in our array. All right, there we go. Now we'll put in. That's again. This is an iteration. There's a sequence there. Iteration, and now we've got to do a selection. If mode array loop counter is, if the one in the loop counter bucket of the mode array is greater than what we currently know as the highest, then we make a note of that. So we'll set highest to be equal to mode array loop counter, and we also remember which number that is, and that's held in loop counter. So the mode will be set to be equal to loop counter. All right? And if that one doesn't change, neither will this. If this is never true, if this statement here is never true, then this won't update. So we'll eventually come out with the biggest one. And at the end of our for loop, what we need to do is just display it. Make sure you come out to the end of the for loop. You could display them one at a time, but that would look a bit silly. So that's simply label mode dot text equals, and again we're going to have to use the convert function, dot to string, And what we want to convert is the mode. And there we go. And if we get rid of that and run it, we're done. Check it out. Mode 67, mean is 62.38. Now, you'd have to test that. That's again not part of this one, but think about how you'd test it. We'd have to actually put in some data that says that 67 is definitively the right answer. But there are some problems. What if there were two numbers that had the same frequency? Say there were 5 67s and 5 72s. How would you deal with that? Because currently I reckon that what it would do is just find the biggest being the first one. We're not saying if it's we're saying if it's greater than. What if it's equal to? If we put greater than or equal to, that would change the outcome. But we're not asked to do that, so I'm just going to save that. Okay, so that's the approach. That's an approach you can use. It's pretty simple. It's really turning the algorithm into valid C# code. It's remembering what the assignment arrow resolves to. It's the equal sign. Remembering how to choose a data structure. Remembering how to choose the correct data type. A floating point as opposed to an integer in this case. All right, cool. All right, work through that. What I'd suggest you'd want to do is actually do this yourself, and then when you've done it, I'm just trying to turn this thing off. When you've done it, you can